Okay, let's start. Hello everyone, welcome to Information Economics. Here I'm going to talk about our second lecture. The main topic today is that I'm going to review for game theory. Yeah, I don't really assume that you have taken a full semester game theory course, but at least today I need to tell you some notion about game theory. And in particular, in this lecture, lecture 2.1, I want to communicate with you about the concept of utility functions and how may people form and have their risk attitudes. Okay, move on. So first I will talk about utility functions, what's the basic notion definition and the concepts about utility functions, and then what's the relationship between utility functions and the risk attitudes. How do people evaluate risks? So the first thing, we need to talk about is about payments, payoffs, and the surplus. Yeah, they are similar concepts. So let's move on. In many situations, what do people do? People do to earn some payments. Okay, that means something that, for example, I sell a product, then I can get payments from those buyers. However, in many situations, we care more about money or payments. Just one very simple example is that when I have something, for example, when I have a television, then that creates some benefits to me, right? So I won't always want to sell my televisions or cell phones to someone else to get payments, because at the same time, I care about my payoff or surplus, which includes all those monetary values of the products I own, about the products I own. So as we mentioned, suppose I have a used laptop. If I feel the only laptop worth X dollars, then I won't sell it. I won't sell it at a price lower than that amount of money, right? Because what I really care is that I want to maximize my payoff. I don't want to just maximize my payments, the total payments I get. Okay, so payoff or surplus include everything I get, include everything I have in monetary values. So a very simple assumption, very natural assumption is that when I have a higher payoff, I will feel happier. Okay, and let's assume this is true for everyone. And in this course, we are not able to talk about those things that cannot be measured in monetary values. Also, we are focusing in the business world. Everything have a monetary values. Okay, so higher payoff, higher payoff increases the happiness is probably true, but this is true only if the payoffs are certain. That means you are definitely going to get something that is having higher monetary values. Okay, but we all know that this world is full of uncertainty or risks, right? So in some situations, you may get some payoffs, but the payoff, the amount of payoff may be uncertain. Okay, we're going to see that this is particularly true when we have information asymmetry. Okay, because when you do not know completely everything, then that creates some kind of uncertainty to you. We'll focus about that later. But here, let's just look at a very simple example. Here I list three payment schemes or reward systems. Okay, so let's see what are them. In situation A or in plan A, you're going to get $1,000 for sure. In plan B, you may get 2,000 or nothing, each of them with probability 1 over 2. Okay, so that's one situation. In situation C, we're going to get 2,000 with probability 99% or nothing with probability 1. In plan C, the probability for getting $2,000 is very high, but again, it's not 100%, so the payment is still uncertain. Okay, so facing these three different payment schemes, if you can choose one, which one will you choose? Okay, that's the basic question. When people have different options, how will they make decisions? Or how will they make decisions? We know different people may have different preferences. In our example here, we know most people would prefer C to B. or in our notion, every rational people should prefer C to B because the payment is the same, but the probability is higher. Okay, but the comparison between C and A or B and A may be difficult. Even if you are comparing C and A, even if most people would prefer plan C, there are still some situations or some people that would prefer plan A because this $1,000 is given to you for sure, right? So different people can have different choices, and we want to have a theoretical framework that allow us to study how people make choices. There are so many different options in this world. Some are certain, some are uncertain. We want to have a simple expression, a simple way to express all of this. Okay, that's how people invented utility functions. In 1947, von Neumann and Morgenstern, they are just great mathematicians and economists. They established the following unified framework to describe preferences under uncertainty by utilities. Okay, this is something we are calling them utility functions nowadays. One thing they show is that suppose one guy is rational, or he is making decisions using his rationalities. Okay, then there exists a real valued utility function, let's call it U, such that given any two random payoffs A and B, like the previous two payoffs A and B, if this guy is going to say he's preferring A to B, then that can be translated into a mathematical expression saying that plan A gives a higher utility, expected utility, than plan B does. Okay? So with this, we are able to translate a very vague expression into a very precise mathematical expression. Some remarks. Rationality here include 4 axioms. For example, one of them is if I prefer A to B and I prefer B to C, then I must prefer A to C. Something like this, which we expect most rational people will follow. And also here we define strictly preferring, strict preference, and there we have a strict inequality. If we have weak preferences, then here is just a greater than or equal to situation. Okay, so let's see some example. Again, we are focusing on our previous example with payoffs A and B. Here our random, which is actually not random, our random payoff A is the fact that we will get $1 or $1 for probability 1. Here A is a random variable. And our random payoff B is that we're going to get B as 0 or as 2, each with probability 1/2. Okay? And we're asking which one we're going to prefer. So suppose we are Alice. Okay? Let's see if my utility function is this one. For every dollar, I get 1 unit of happiness. Then I'm going to ask which payoff will I prefer. Okay, so what I should do is to do an expectation, right? I should just calculate the expected utility I can get under the different two payoffs. So expected U of A. In this case, I know A has only one realization, it's just 1. So all I want to do is to calculate utility 1, and it's 1. How about B? I'm going to calculate this. And here, B has 2 realizations. It may either, with probability 1/2, it may be 0, or it may, with probability 1/2, it is 2. Okay, here I need to remind you one thing. This 0 is actually U of 0, and this 2 is actually U of 2. Okay? It's because that Alice's utility function is so special that U of 2 is 2, so that when we are calculating the expected utility, you get this expression. and that's how we get 1. Okay, so in this case, because utility A gives you an expected utility 1 and B gives you an expected utility 1, so we say these two payoff payment schemes are just equivalent. Okay, then let's see example. Suppose Bob has a different utility function like this. Okay, let's again calculate what's going to happen. So for plan A, here I know plan A has only one possibility, it's just $1. Okay, so when Z is 1, when Z is 1, my payoff is 1. Okay, so again I still get 1. So now how about the other one? Here I need to calculate 1/2 times u of 0 plus 1/2 times u of 2. Okay, for u of 0 is 0. You can see this here. When Z is 0, you get utility 0. But when utility is 2, when the payment is 2, your utility is 1. Okay, and finally, your expected utility is 1/2. Then in this case, we're going to say that for Bob, he is going to prefer plan A because plan A gives him a higher utility. Higher expected utility. Okay, so for that concept, we are saying that we are using the framework of von Neumann-Morgenstern utilities. Starting from now, whenever we say we are calling something like a utility function, that means von Neumann and Morgenstern utility functions. Okay, under this framework, all those rational persons will act for the same reason. They want to maximize their expected utility. Okay, now I have a very simple way to formulate how people will make decisions. All they want is to maximize their expected utility. The only reason that people behave in different ways is because that they have different utility functions. Traditionally, when people invented this system, we only care about those things that with concrete monetary values, such as money, products, or cost, and so on. But afterwards, in nowadays, many people are caring about things like utilitarianism, which means I want to make other people happy, or fairness, which means when I am allocating something, I want everyone can be happy. Okay, I may incorporate these more complicated things into my utility function to model some people's special behavior. Okay, in the economics or business world today, most of the time we talk about von Neumann and Morgenstern utility functions, even though there are some drawbacks, but we're going to just stick our attention to von Neumann and Morgenstern utility functions. One thing we can say for sure is that this may not be true for everyone, but this is valid for most business decisions because typically we are focusing on business entities like companies, like firms. Even though an individual person is not completely rational, most of the time a company is indeed in some sense rational. They have a clear goal, they want to maximize their profit, and so on and so on. Okay, so we're going to stick our attention to von Neumann and Morgenstern utility functions starting from now. Okay, now let's talk about risks. So again, let's focus on our example with payoff A and B. We say that people may have different preferences for these two guys. Why? Because people have different attitudes for facing risks. In particular, when we say one person prefers A, this with no risk, typically we say he or she is risk averse. he or she does not like risk. Or on the other hand, when we have these two payments, but one person prefers B, then we say it is risk-seeking or risk-loving. Or if someone is indifferent for these two payments, we typically say she is risk-neutral. Okay, risk-averse, risk-seeking, or risk-neutral. So go back to our example. We say Alice is risk-neutral because when we calculate the expected utility for Alice, these two payment schemes are the same. But Bob is risk-averse because we say Bob prefers plan A to plan B. So Bob is risk-averse, at least in our environments here. Okay. So in general, it's very hard to describe one's risk attitude. But in our world, in economics, typically we adapt this conventional assumption. The shape of one's utility function describes how he or she is going to face risks. So the conclusion is here. I'm going to say that one guy is risk averse if and only if his utility U is concave, or he is risk seeking if and only if his utility is convex, and one is risk neutral if and only if U is linear. So now we can see we want to study how people will behave, and that critically depends on his risk attitudes. And to describe risk attitudes, we really need those mathematical tools like concavity, convexity, and linearity. Okay, so this is an assumption, so there's nothing to show you why. But at least I want to intuitively tell you that these are something making sense. Okay, so let's see this. We say that Alice is risk neutral and Bob is risk averse. So we want to ask, are their utility functions really linear and concave? Okay, so for Alice, U of Z is exactly Z. So when you draw the function here, this is Z and this is U. Indeed, this is a linear function. How about Bob? For Bob, when Z is below 1, the utility is like this. And when Z is above 1, the utility remains unchanged. Okay, so this is indeed a concave function, and indeed Bob is risk averse. But you may just say that this example is just so restricted. Do we know the assumption is reasonable in general? Here is the time for us to apply what you have learned in homework 1. We're going to talk about Jensen's inequality. Okay? So you know doing homework is worthwhile. So let's see this. I'm considering a random pair of x. I don't know what's the amount I'm going to get. And a concave utility function. Let's assume I have a concave utility function. Then I know this. What's this? This is given by Jensen's inequality. The expected utility is less than or equal to the utility of the expected payment. Okay? What does that mean? That means I am offered a plan. This plan gives me a random pair of x, and I may get some dollar, and that may create some utility value. And I'm asking what's the expected utility. Okay, that's one side. But instead of having this, I always prefer what? I will always prefer to be offered the expected payoff. Okay, it's always the case that I don't care what's the maximum amount I may get in the best case. I just ask you I just ask that please simply average all those possible payments to me, and I want one payment for certain. Okay, if you look at this more clearly, here this is a random variable. Okay, you don't know what's your payment, so you don't know what's your utility. But here this is deterministic. This is a certain payment. Okay, you just ask for the expected payoff, and that's going to create a higher benefit, a higher utility to you. Okay, so what does that mean? When this relationship is true, that just means you are risk averse, right? I don't want any risk. All I want is just give me the expected utility. Okay, and when does this become true? When your utility function is concave. So now we are able to link everything. Concave utility function, according to Jensen's inequality, you have this. And this tells you that you are risk averse. So indeed, concavity and risk averse are somewhat equivalent. Okay, and another thing is that here, when you have this, you have a concave utility function like this, and that means a very high payment only give you a not so high utility. Okay, so that's the interpretation. Okay, when U is convex, then everything becomes reversed. Expected of utility and the utility of the expected payment. Here we know that the first one will become higher. So instead of asking for an expected certain payoff, I would like to take some risk to have the chance for getting a higher utility. And also in this case, a higher payoff creates a really high utility. Why? Because the function, your utility function is convex, something like this. So when you have a high payoff, that's going to give you a very high utility in this case. Okay, and finally, U may be linear, and in that case, if you want to maximize the expected utility, all you need to do is to maximize your expected payoff. So, as a summary, concave utility functions tells us that this guy is risk averse, and convex utility functions tells us that this guy is risk seeking. Okay. Finally, I want to make a remark on something we call beliefs. So we know there are some risks in every action, but how risk it is depends on how do we evaluate the possibilities of outcomes. Okay, so these risks, these probabilities of outcomes may sometimes be objective, but sometimes may also be subjective. Okay? And in that case, we say people will act according to her belief. For example, when I am doing a gambling, I need to form a belief about whether the dice is fair. If I believe this dice is fair, I may participate in a gambling, right? But if I believe this dice is unfair, then probably I will just leave. I make my decision according to my belief on whether the dice is fair. Also, when I want to make a decision on whether I want to bring an umbrella tomorrow, then that depends on my belief about the chances of a sunny day or rainy day. And then naturally you will realize one thing. When people have different beliefs on the same thing, for example, the weather tomorrow, that's just one thing, but different people may have different beliefs on it. Then different people with different beliefs may act differently. Okay, so for every possible event, we need to form a belief and we act according to our beliefs. Different people have different beliefs, so they act differently. Okay, so that's the end of our introduction or our discussion about utility functions and risk attitudes. We're going to use them in a short time in this semester. Later, in the next video, we're going to start our introduction about game theory. Thank you.